Hey, everybody. We're back again here, and we're going to do some more work with our complex numbers, part 2. Okay, so we've already added, we've subtracted, and we've multiplied with our complex numbers. We're going to do some division now, show you how that works. Okay, so here's an example. Start with, let's take 2 plus I, and we're going to divide it by another complex number, let's say 3 minus I, for example. Okay, now it's not a long drawn out process like let's say long division of polynomials, for example. What we do here is we're going to take and treat it as kind of like a rationalization problem. Since we know this I involves a radical, we're going to use the fact that if you take well, if I have a number a plus bi, then its conjugate is a minus bi. And when you put conjugates together as a product, a minus bi, you end up with a squared middle, and you have a minus abi, and then this third product you have a plus abi, and the fourth product you have a minus b squared I squared. Now the middle two terms cancel because they're opposites, abi and minus abi. So we still have a squared, and over here you'll have a minus b squared, and then you'll have the I squared, which is also a negative 1. Okay, so I squared is negative 1. So that makes this a squared plus b squared. Okay, so notice what happened though. The idea is that we started with 2 complex numbers, this number and this number, and when we found the product, we end up with a pure real number. So what this will do is we'll be able to get that I out of the denominator and into the numerator, and then we can write a result. Whatever that is, we'll be able to write it in standard form. Because right now, this is not standard form. So let's try it. Let's see what happens here. 2 plus I, 3 minus I. So we'll use the conjugate on this, which is a 3 plus I. And I'll put that same 3 plus I up here. Whatever I multiply the denominator by, I do the same in the numerator. So now let's go ahead and find that product up on top. We'll have a 6 plus 2I, okay, this times and this times. And then we have another 3I in the middle, and then finally an I squared on the end. Okay, so that's the numerator. Now the denominator, you can see what's going to happen is, well, let's take it through the long way just so you know how to do this. If your memory fails you on the shortcut, which is this over here, you can take it the long way. 3 times 3 is 9. 3 times I is 3I minus 3I here, second product, and then finally minus I squared. So let's go ahead and simplify the numerator, which is 6 plus 5I minus I. Whoops. Where's that thing there? Okay, let's fix that. That should not be there. Let's try that again. We got an I squared, which is a minus 1. Okay, so that's from the numerator. And then down here, you're going to have the 3 i's cancel. You got a 9 minus negative 1, because that I squared is a negative 1. So that will finally give us 5 plus 5I over 10. Now you can leave it like this, it's okay. Strictly speaking, though, to have the standard form, you'd have to write it this way. And that's could also be written this way, 1/2 plus 1/2 I. Okay, so that's another way you can write the same thing. And this is in your form. This is the A plus the BI, the standard form. Okay, so now let's take another one of these. Okay, let's try this again. Another example. Let's do I over, let's say, 5 plus 3I. Okay, all right. So you start off and your first step is to write that product now. I'm going to take this denominator and multiply it by 5 minus 3I. And same thing up here, 5 minus 3I. Okay, so you introduce that. That's the conjugate of the denominator. And then I'm just going to leave that I. Well, I'll multiply it out. I have 5I minus 3I squared in the numerator. And down here, you're going to get, remember the middle terms drop out. You can notice what happened over here. Those middle terms, they drop down. They're always going to drop out. All you're going to end up with is 5 squared, which is 25. And then minus 3 times 3 is 9 with an I squared. And I'll at least show that much work. Okay. And now that numerator is 5I minus 3 times negative 1. So I squared is negative 1. And 25 minus 9 times negative 1, because that's I squared. So this is 5I plus a 3. And down here we have 25 plus 9. So let's straighten this out. We'll have a 3 plus 5I, and it's divided by, was it 34? Which you can then write as 3 over 34 plus 5 over 34I. And there's your standard form for that number. Okay, for that final answer. All right, now let's look at another problem, related problem. So now we have down, we've got addition, we can do that, we can subtract, we can multiply, we can divide. Okay, so there's one other operation we're going to look at, and that's powers. Okay, in other words, raising to powers. So exponentiation we're going to do. So let's do an example. Let's start with, say for some reason you end up with I to the 7th, I to the 7th power. Okay, I to the 7th power. Well, it's not standard form, that's for sure, because standard form would look like this, A plus BI. Now the A can be a 0, and then you just have a BI. But this is not BI, this is 1 times I to the 7th. So we need to get rid of that 7. Somehow turn it into a 1, or if not a 1, then maybe this thing is real. Who knows? So here's how we do it. We write this as I. There's a lot of ways to do this, but this is one way. Okay, using your exponent rule, you can rewrite the I to the 7th like so. I to the 6 times an I, because that's first power. Okay, now remember these i's, it behaves just like a variable or any other real base that we raise powers to. We have the same properties that we can use. Now that I to the 6th, the reason I did that was because I could write like this. I to the 6th, and then leave this I here. The reason I did this is because I to the second power is a negative 1. And negative 1 to the 3rd now is just a negative 1 I, and we would just write this as a negative I. That's now standard form. Okay, that's standard form. It happens to be pure imaginary. You could say, oh, that's 0 minus I. And there's the real part. The real part is the 0. But you don't normally write the 0. People just leave it this way. Standard form is just fine. So the real part of a pure imaginary number is 0. It's not there. Okay, you don't have to write it. I mean, it exists, but it doesn't change anything. That's the idea. Well, the properties of a 0, they don't change anything when you add them. So, all right, so that's that. Let's do another one of those. Let's say I have I to the 52. Let's say I to the 52. I don't know when you'd ever see that, but this will illustrate the process. I can immediately write that as I squared to the 26, since it's even. Notice in the first problem, I didn't have to, I needed to get it to be even first before I could do that. And that's why I pulled out one of the i's here. This is -1 to the 26, and any negative raised to an even power, we remember, is always going to turn out positive. So it ends up as a 1. So I to the 52 is actually just a 1. Okay, and let's say I have this thing, I to the -5. Let's say a -5th power. Get that in standard form. Well, again, the negative, we'll work on that negative like so. It's I to the 5th in the denominator. Okay, well, how do you get that to go away from the denominator, so to speak? Well, typically, you'll do this. You can say 1 over I to the 4th with another I. And that could be written as 1 over I squared I. That's just 1 over -1 squared I, which is just 1 over I. Okay, so we're getting closer, right? And it's still not good enough. But now I remember how to get rid of an I. I'll multiply one more time. I'll do this. I, like that. Okay, now technically I could use the conjugate, which is a negative I. Okay. A negative in this case doesn't bother us too much, but I can use the conjugate. Makes that a negative I up there. Down here it makes it negative I squared. Well, one more step gives us negative I over -1, which is negative I. And that's my final answer. Now that was one way to do the problem. You can play around with these and experiment. It doesn't have to be exactly the way I did it. You can, you might say, you know, maybe I'll try this. Instead of that first step with a negative, changing it, you might say, well, if I can do things here, what if I just multiply that by an I right away? And the denominator by an I right away. Then that would give you I to the -4th over I. And that -4, still got to deal with that negative. If it's not going to go away just because I did this, right? So maybe you try I to the negative. Well, let's forget that. Write that. Whoops. What happened to that? Okay. All right. So I'm still kind of stuck here with this negative here. This I to -4 over an I. I still got to get rid of that negative. It's not going to go away. So you might say, well, let's move it back down again. So let's write it 1 over I to the fourth like that. But notice I'm back where I started over here. So then I have to do the same things that I did there, or I could do the same things. So let's see, what else could we do with that? Might change it, might make it easier. Well, this is one way to get the problem done. It's good enough for now. Let's see. Let's try something else here. Okay, I wanted to show you another approach to this. Sometimes you'll find this in different textbooks, and that is, if you notice over here, I is I squared is -1. I cubed is just an I squared times an I. So that's a -1 times an I, like this. Okay, I to the fourth is I cubed times an I. So it's a negative I, or you can say it's I squared times I squared. You get a +1. I to the fifth is I to the fourth times an I. So that's 1I. I to the sixth is I to the fifth times an I. So that's I, just a -1 again, I squared. And you could, you keep repeating this, and what you keep going down the line here, I to the seventh is I to the sixth times an I. Well, that's -1 times an I. I to the eighth is I to the seventh times an I. So that's -I times I, which is -I squared, which makes a +1 again. This just keeps repeating every four integers, every 4 natural numbers here. We get the repeats again. So what you could do is this. You could say, let's say we have an expression like I to the 34th power, let's say. And we already saw how we can handle this with the I squared, but you can, if you think about that 34, if you divide it by 4, you'll get 8 with a remainder of 2. So that 2 means that this will be I squared. And we know that that's a -1. So there's your answer. Was that faster than the other method? Here's the other method. I squared to the 17th, which is a -1 to the 17th, which is a -1. You still have basically the same number of steps here. And I didn't have to do this over here. So let's try another one. Let's do I to the, let's go 56, for example. Well, divide that 56 by 4. Okay, so if it's easily done mentally, that's 14, right? 14 with a remainder of 2. Okay, well, wait a minute, it's an even 14, sorry about that. It's an even 14. Get rid of that. Okay, let's try that again. Okay, divide 56 by 4, and you get even 14. So you have a remainder 0. That means this will be I to the I. What is that? Why did that come in there? Let's get rid of that. Leave that out of there. Okay, so that's I to the 0. Okay, I use that 0 there. Well, that's a 1. Anything to the 0 is going to be a 1. Okay, so we know I to 56 is 1. All right, let's try an odd power here. You can see how that works. Got a couple even ones there. Let's try another one here. Let's do I to the, I don't know, 75. Okay, well, if you divide that by 4, let's see, you're going to have what? 4 to 60 would be 15. So you got there 12, 72. 72, 9, 16, 19. Yeah, so it's a 19. Or, oh, let's see, it's not 19. Oh, I got to do that arithmetic. Here, let's try this. Okay, it's 18.75. So we can get it in there. 18 times and remainder 3, right? So, okay, yeah. So we got remainder 3. We got 18 with remainder 3. Yes, 72 and then remainder 3. So that remainder 3 means we have I to the third. Well, if you've got these patterns memorized, we know we really only have to remember the first 4 because they always repeat like that. And every time we do this, when we divide by 4, we're never going to get anything other than 1, 2, 3, or 0 remainder. So there's only to remember those 4 cases, really. So if you got that memorized, then you know that that final answer is just a negative I. Okay, so this is another way. If you were doing a lot of these, this would be kind of a neat way to just to help you remember it. But I don't think it's really better than what I showed in the first place. In other words, if I hit I to the 75, I would just do I to the 74 times an I, and then I would break this in half with a 2 here and a, 37, right? And that would become minus 1 to the 37, I, which is a negative I. About the same amount of work. I don't have to remember anything except what I squared is. This method forces me to remember what I cubed is. Okay, so it's half a dozen one, 6 of the other. Anyway, so that is how you handle the powers. And that's about it for complex numbers.